Let's look at question number 2. We have a cart on some tracks. Okay, so once again, our cart can only move in, the XY direction. We have 3 people pulling on the cart. Jessica pulls this way with a force of 121 newtons. Then we have Ben that pulls on the cart in this direction with 153 newtons. And we said that this is 22 degrees because it's 22 degrees north of the west axis. But again, we have to choose this to be the XY coordinate system. So we're going to measure everything from, we're going to measure our angles from the positive X direction. So we have to find out what this angle is. So this angle is 22 degrees. This angle's got to be 158 degrees. So we're going to measure it from that angle there. Okay, so we got to choose a system to measure it from. We can't measure it from here and from here. We have to choose this to be our coordinate system. And then we have a third person pulling, let's see, Toby, pulling with a force of 321 newtons at 90 degrees from the positive x-axis. So let's just answer these in turn. Part A says, how much work is done by Jessica? It's simply work is equal to force times distance is equal to 121 newtons times, I said that they go, what, 35 meters? This is pulled for 35 meters. Make sure that's correct, yes. 35 meters, and this first answer is 4.24 times 10 to the 3 joules. That's how much work is done by Jessica. B, how much work is done by Ben? Work is equal to force times distance. Since Ben is pulling at an angle, we have to use cosine theta. Don't worry about whether this is the opposite direction or not. This angle, theta, will take care of whether the sign is positive or negative. So it's going to be 153 newtons times 35 meters, that's how far you pull it, times the cosine of 158 degrees. And this number is negative 5.00 times 10 to the 3rd joules. Okay, so this is the answer of part B. Notice that, the X component really is going to be like this. So but it's going to be negative 5 times 10 to the 3rd joules worth of work. C, how much work is done by Toby? Well, really quickly, you can see that Toby's pulling at 90 degrees to the direction of motion, so he doesn't do any work at all. Because if you got a train car that can only run this way and someone pushes or pulls in that direction, the train car is not going to move. And you can really write that as work is, you don't have to do this, but work is equal to FD cosine theta, and you find that cosine of 90 degrees. If you type in cosine of 90 degrees, the answer is 0. This is 0. So force times distance times 0 is equal to 0. So any number multiplied by 0 is going to be 0. So I don't even have to go through any kind of work with that. D says, how much work is done by the carts, how much work is done on the cart by the students? So we're simply going to go 4.24 times 10 to the 3rd joules worth of work plus negative 5.00 times 10 to the 3rd joules worth of work by the other person plus 0 joules by Toby is equal to a total of negative 770 joules. That's how much work is done by the 3 students. Now, work is also done by friction. So let's look at E. How much work is done by friction? It's simply the opposite. So if there's negative 770 joules worth of work done this way, friction does positive 770 joules worth of work. I mean, you can simply look at it as the work total. You don't have to do this. You can just write positive 770 is equal to the work done by, let's see, who do we have? We have Jessica plus the work done by Ben plus the work done by Toby plus the work done by friction. And I know that the work total is 0. How do we know the work total is 0? Because I say that the cart does not accelerate. It moves at a constant velocity. So don't forget, if there is no change in kinetic energy, if there's no change in speed, then the work has got to equal 0. So if this is 0, if there's no change in speed, then this also has to be 0. So 0 is equal to the work done by Jessica plus Ben plus Toby, and we don't know what the work done by friction is. Let's just say we know it's actually positive 77. So if I rearrange this equation, it's the work done by friction is equal to the opposite of work done by Jessica plus the opposite of work done by Ben plus the opposite of work done by Toby, and that's equal to 770 joules. That's your answer. So again, plus 77 joules if you fill in these numbers here. Remember, this is actually 0. Look at part F. What is the total work done on the cart? Since the cart does not accelerate, there is no change in kinetic energy. Kinetic energy, the change in kinetic energy is equal to 0, then work is equal to 0 joules. All right, that's it.